Okay, we're going to do the notes for 10.5 Part A. And Part A is finding the distance between a point and a line. Now it's the process to find the distance between a point and a line is a three-step process. It's going to take some space on our paper. So what I did was I whited out examples number 4 and 5. You can just cross it out or white it out as you choose. We're on page, by the way, we're on page 299 of your student journal. Okay, so before we get started, we're going to do example number 3, which is finding the distance between the point A at 0, 5 and the line y equals negative 3x minus 5. I'm just going to make a sketch and explain the 3 steps that we need to do, and then I'll use this space up here to list out the 3 steps in abbreviated form, and then we'll perform the 3 steps down the page. So just making a quick sketch of the point in the line we're talking about. We're talking about the point A here at 0, 5. And then the line y equals negative 3x minus 5. So the y-intercept is here at negative 5. We have a slope of negative 3. So that line's going to look something like that. So y equals negative 3x minus 5. So we know the shortest distance between a point and a line is the the perpendicular distance. So I'm just going to sketch in what I think would be the perpendicular there. And then, so to find the distance between this point A and the point where the perpendicular meets it, we need to first find the equation of this line. So that's step 1, find the equation of the perpendicular line through the point 0, 5, the line that's perpendicular to our given line. And then secondly, find out what this point is, what this intersection point is. And we're going to do that by solving a system of linear equations. And then third, use the distance formula to find the distance between those 2 points. So first step, step 1, find the perpendicular line equation. Step 2 will be to find the intersection point. By solving a system. And step 3 is find the distance between the points using the distance formula. So step 1. So this line that we're given has a slope of negative 3. So we know that the perpendicular slope is going to be positive 1 over 3, the opposite reciprocal. Our original slope was m equals negative 3. We want to find the perpendicular slope, which is going to be the opposite reciprocal of negative 3 over 1 is positive 1 over 3. And we have a point. We have the point 0, 5. So there's our m. Here's our x1 and here's our y1, and we'll use the point slope formula, which is y minus y1 equals m times x minus x1. I should have labeled that this is step 1 here. And plug in the x1, y1 in the m, and we get y minus 5 equals 1/3 x minus 0. Now I know a lot of you are probably saying, why is she using the point slope formula when we already know the y-intercept? But I just want to show you the process just in case it's not quite such a friendly problem. So using the slope or the point slope formula, the next step is to distribute the 1/3, and we get y minus 5 equals 1/3 x minus 0, or just x. Add 5 to both sides, we get y equals 1/3 x plus 5. So that's the equation of this line right here, y equals 1/3 x plus 5. Now our goal is, or our intermediate goal in step 2, is to find out where our original line crosses our perpendicular line, because we need that point right there. So we're going to do step 2, which is solve the system of equations. First, y equals negative 3x. Oops. Uh-oh. Sorry. Pause and get all that stuff that I wasn't showing you. Sorry about that. I don't want to start all over. Okay, so our first equation, the equation of our original line was y equals negative 3x minus 5. And we want to find its intersection with the line y equals positive 1/3 x plus 5. And so we need to solve the system of equations to find the xy ordered pair where that makes both of these equations true. So since they're both in slope-intercept form, they both have y equal, I am just going to, since they're both equal to y, the x expressions are both equal to each other, I'm going to use substitution. Negative 3x minus 5 is equal to 1/3 x plus 5. And let's see, we need to get all the x's on one side. But then I'm going to have to subtract 1/3 x from both sides and deal with mixed numbers. I think I'm just going to go right through right now and multiply both sides by 3 just to clear that 1/3 in my denominator. I'm not in the mood for dealing with fractions today. So I'm going to multiply this whole side by 3 and multiply this whole side by 3. Did I leave room? I'll just distribute backwards. So 3 times negative 3x is negative 9x. 3 times negative 5 is minus 15. 3 times 1/3 x is x. 3 times 5 is positive 15. Okay, that looks better. Now, I'm going to, just so I don't have to have a negative x, I'm going to add 9x to both sides. Now that's going to get my x's on this side. I'll have 10x. So all in one step, I'm going to subtract 15 from both sides. So negative 9x and 9x make 0. Negative 15 and negative 15 make negative 30. Bring down my equal sign. X and 9x make 10x. And negative 15, or positive 15 and negative 15 make 0, so those will cancel. Divide both sides by 10, we get x equals negative 3. So I know that the x-coordinate of this intersection point is negative 3. I have to find out what the y-coordinate is, and I'll do that by taking this answer, x equals negative 3, and plugging it into one of the two equations that I started with. Either one is fine, but I think I'll do the top one just because it's got the whole numbers. So to find out what my y is, I get y equals negative 3 times negative 3 plus 5. Uh-oh. Minus 5, I'm sorry. And y equals 9 minus 5, or 4. So the intersection point is negative 3, 4. Oops, I need a second parentheses there. So we found out that this point right here, let's call it B, is -3, 4. So now we're down to our third step. Good thing we're running out of room. So step 3, scoot it up. Step 3 is to find the distance between our original point 0, 5, which was A, and this new point that we found, B, which is -3, 4. So I'll use the distance formula. Distance is equal to square root. Do we need to write the formula? I'll do it. X2 minus X1 quantity squared plus Y2 minus Y1 quantity squared. Substituting in my X1, Y1, X2, Y2, we get -3 minus 0 squared plus quantity 4 minus 5 squared, which is the square root of -3 to the second power is a +9, plus 4 minus 5 is -1 to the second power is +1. So our distance is square root of 10, which is approximately, am I off the page yet? Nope, you can see it, 3.2 units. So we found the distance from this line, y equals, this line, y equals -3x minus 5, and this point 0, 5, by first finding the perpendicular line between that point and our line, and then finding the intersection of the perpendicular with our original line, and then third step, finally finding the distance between the 2 points. And the next lesson will be to find the equation or the distance between 2 parallel lines. Thank you. Have a good day.